In the previous sessions, we have learned how to calculate the cost and how to perform different experiments by changing the inputs such as angles of rotation and how does it affect the cost. In this session, we will learn how to nest a part on the build platform. That means how many parts can be fit at once on the given build platform. Imagine doing this manually by changing the angles of rotation and performing different experiments in order to find out the optimal number of parts that can be printed at once on the given build platform can be a tedious task. So in this session, we will learn how to do this automatically. Please open the file LBM Nesting Starter. So in this file, we already have the geometries that we want to nest. So we have different geometries in this workflow. Later we will see how does the workflow runs automatically when we switch the geometry. We also have other types of geometries here, which are obstacles. That means those are the no-go areas for printing or nesting the part on the build platform. So we have some of the geometries like these ones and the other ones like this. So before we perform the nesting, it's required to unite both of these obstacles such that the output is only one single body. So to do that, we can use this component union and then turn this to general topology on so that the output is only one single body. So now we will perform the nesting. To find the component, we can go to the tab AM and analyze and find the LBM nesting here. So we can take the component and place it here in this step, or one can also search like this LBM nesting and you will find the component like this. So as we can see, the part mesh is the mandatory input for this component LBM nesting. So it has to be a mesh. So let's input this mesh. So here we can see that the given part has been nested on the build platform. So here there are also other options. Let's have a look at them. Here we can also define the machine dimensions, which are X, Y and Z, like these ones. And the part gets nested on the build platform like this one. So here we can see that these are the specimens or the no-go areas for nesting the given part, but here we haven't specified or given them as an input. So let's input that. And now we can see that the part has been nested such that it does not collide with the specimens or these obstacles. So here are some of the other inputs that we have on the component, which is distance to the edge. That means distance to the build platform. So if we increase this value, then we have like more distance from the part to the edge of the platform. And here we can also define the distance between the two parts. So if we increase this value, we can observe that the number of parts now will be less. So here we also have another important parameter, that is Z rotation. So if we turn this off, we see that the actual orientation of the part will be used as is on the build platform while nesting this one. But if we turn this on, it also finds out the optimal number of parts that can be printed or nested. So here we can see that the computation took a bit longer as we turn this option on, but we can also see that it tries to find an optimal orientation such that it can nest as many parts as possible. So this is one of the important parameters. And we also have this one, only use XY projection. That means, for example, if we have like the 3D parts, let's change it to a different part, which is L-shaped 3D, which looks like this one. Here we can see that there is one part inside the other part, although there is like some distance between them. So if we turn this option on, use only XY projection, then one part doesn't go inside of the other part. So here we will observe the result now. as we can see that the parts doesn't go inside of the other one. So this is the basic functionality of this component, and here we observe that we can switch between different geometries, and then this component will automatically nest the given part on the build platform. So as an output we get the mesh of all the nested parts on the platform, which also has the new orientation of these parts. And here we can get the total number of parts that could be nested, and here we have the transformation matrices of all the parts on the build platform. So this is the end of this course, cost driven design. In this course we have learned how to calculate the cost of laser beam melting parts, how to perform different experiments and parametric optimization by linking various parameters of interest such as angles of rotation, total cost, cost per part, the total volume of the line supports, and so on to the parametric optimization. And we have also learnt how to perform nesting of a part on the build platform such that we optimize the usage of this build platform and print as many parts as possible at once. I hope you enjoy this course.